Yo, so you'll notice I have forgone wearing the lab coat, and I'm wearing a chef's jacket because I hope to cook with you guys tonight. That'll all be clear in like 10 minutes. So I'm Cameron Dershem. You can find everything about me at pinkcatbeard.com. I'm a software developer, consultant. I also am the co-founder of an IoT startup named Ocelli. We connect time-worn problems to 21st century solutions. Basically, we make sensors and the networking to connect those sensors. So let's move straight into it. Decorators. Who here actually knows what a decorator is? Who thinks they could actually explain what a decorator is? And who uses them daily? And who writes their own occasionally? I'm not buying it, Joe. What the heck, Joe? That's vulgar. All right, so let's go into an example. Right here on line 4, you see the @ sign with the app.route and the symbols there. That is a decorator. This is the hello world from Flask. I'm sure we're all familiar with it. If you've ever wondered how that works, hopefully by the end of this talk, you'll have some idea of how that works, and you'll be able to write a very similar thing yourself. So, decorators, a denotation. So I'm going to use a lot of really big words here for a second, and you don't need to know what they are, but if you do want to know what those words mean, Neil Tomlinson is sitting right back here, and he would love to explain what they mean all to you after this. Decorators are a type of higher order function in Python. So what that means is they are a function that takes a function as an argument, or a function that returns a function. They're very similar to macros in other languages. One of the articles that I referenced at the very end in the resources section, they have this quote that they provide a simpler alternative to meta classes. You don't actually have to know what any of that means, but these are all words that I wish someone would have said out loud to me sometime when I was starting, so I at least knew that they were things that actually do exist in Python. So what does that all mean? This is a decorator. It is a function that wraps another function. It extends it without actually modifying it. So you see here, we have a cute, adorable kitten that is now covered in a blanket, sleeping in a bed. That was all done without actually editing our go-to-bed function. But we were able to modify what happens when you call that actual function. So I'm going to show you how that works. Well, first, actually, I'm going to explain why you'd want to do that. So here's a pattern that we all use all the time. It's the DRO method. It's do repeat yourself. So you notice that each one of these methods here has the same first couple of lines. So we always check to see if a user is logged in before we actually do anything real. So this is a really bad pattern to follow, right? It smells bad. There's a lot of repetition. It leads to a lot of really crappy maintenance. It'll lead to bad testing. It will give you a bad bug some point in your life that you'll never be able to find. So this will be the exact same code here on this page, but without any repetition. So we've created this wrapper function here at the top. The top there is a decorator. We'll explain how that works here in a second. And now you can see we only have to repeat one line when we define the function, but when we call the function, we don't have to do anything different. So therefore, anyone that's actually using your library's API doesn't actually need to know that the decorators ever existed. They just know that it magically knows beforehand that it checks to see if someone was logged in. So how does that work? So here we've got a function we call decorator, and you can see that it takes a function, and then inside that function it actually defines another function. And then it does something before it. It then calls the function that was passed in, and then it does something after it, and then it returns that wrapper function. Now, the reason that they're called wrapper and decorator is because the names mean nothing in this case. That's not important. And then you can see here down at the very end, we call the decorator, we pass it the function, and we set that return value to the decorator return value. And then I print that out, and I'm showing you here is that what we're actually returning is a function. We haven't called that function yet. So what we've done is, so now there's actually extra steps that you have to do to be able to do this. So then at the very end here, we call that return value, which was the function, by adding the parentheses to the end of it. We now call it, and that causes the before and after to print. So this is the exact same code, but now we're actually using a decorator as opposed to doing it manually with a function. So here, the only thing that changed, if we go back, is instead of calling it with 3 lines, we just added that @decorator syntax, and now we don't have to do any of that other crap. So the decorator is actually just syntax sugar for all of these 3 lines there. And I can prove that on the next slide by, if you look at the bytecode that Python actually generates when it's compiled, is the exact same. So this results in the exact same thing as that, as far as the bytecode is concerned. So now that you've seen a little bit of that, this is the actual Flask, that app.route. This is the source code. I've taken out one line in here that was confusing. It does not matter at all. It actually, I don't even know why it's there. It's never used in all of the Flask source code that I could tell. But so you can see all you're doing when you pass that app.route is calling another function. So all that does, you could actually just as easily add a route manually to Flask by calling app.addURLRule and then passing that same parameter to it. So one problem with decorators is, you see here, I've added, this is the same stuff that we had before, but I've added doc strings. And then here, I'm asking Python to print out the name of the function I'm calling, and also to print out the doc string for the function I'm calling. And you can see the result is it tells me the wrong answer. What's actually doing the right thing, it's that I have tried to break Python by doing it the way I was doing it, because this is all kind of magic stuff, right? So because of that, Python has this nice module built into the standard library called functools. Functools is where you can find everything that anyone that writes like a statically typed, more traditional language than Python that tells you that Python's not a real language, that it doesn't do this, that, or the other, every single thing they tell you that doesn't exist is actually in the functools module, because Python does it all. And so in the functools module, there is a thing called wraps. Wraps is a decorator itself. And if you look at the source code, it's kind of cute because they went out of their way to make it a decorator, because it doesn't need to be a decorator at all. But so you pass here, you can see all you do is decorate the function with the wraps, pass it your function, and then when you call to ask for the dunder name and the dunder doc, it prints out the right things here. And this is all because Python is, all it's doing is lying to you. It's actually still calling that wrapper function. It's not actually calling this load secret function. It's calling a function called wrapper, but that decorator up there tells Python to know to lie to you about it. Because Python, as Raymond Hedinger would say, is a consenting adult language, so you know that it's going to lie to you and you're okay with that. So here is a recipe for decorators. In the 6 years I've been writing Python, I've probably been writing decorators for maybe 4 to 5 years of that, and I have never once needed a decorator that was more complex than this. So feel free, when you copy my slides, you can copy and paste this out, and this will get you through 99% of all your decorator usage. All you have to do is change the name of the decorator to something that's semantically meaning for you, maybe add a doc string in there and make it do something. But this decorator is the perfect example of everything. The only problem was, when I was writing this talk, I learned a few things. And you shouldn't try to do that. It's bad to learn new things, as you'll learn from Nick Birch in the next talk. So what happened was I learned that there's actually a lot more complexity to decorators than this magic little recipe. And that is passing arguments to decorators. So this is how you pass an argument to a decorator. So you can see here I'm passing a positional argument named arg, and then a keyword argument named key to this decorator. And this looks a lot more complex, but it actually, all it does is add one more layer of an extra function in there, because you actually have to be able to ask for both the decorator's arguments and the function that you're decorating's arguments. So I'm not going to explain how this works too much, but if you try to dissect this and you play around with it for a minute, you'll figure it out. It's not that much more complex than the regular decorators. And then here is another thing I learned, which is another way to write decorators. And this might make things a little bit more clear, it might make things a little bit less clear. It just depends on how familiar you are with Python classes and magic methods. So here you can see that, so what a decorator actually is, it's a function that, a function that takes another function, right? But what is a function? A function is anything, any object in Python that is callable, right? So what is a callable? That's anything that defines a dunder call method. And so here you're taking a class, you create the initializer, the init function, which takes the arguments. Then you take and you make the callable, the dunder call, and that actually does the work for you. And the thing that you actually can't see on this slide, which I should have made an example of, is one gotcha with decorators that you'll run into occasionally. It becomes very clear with class decorators, is that the init and the call don't happen in the same place. So the init actually happens on this line, so when it's declared. The call doesn't happen until this line. So that won't matter 98% of the time, but at some point in your future you will run into a bug, and that will be the answer, is knowing that it gets initialized at the declaration but not called until the function that it's decorating gets called. So what are some typical uses of decorators? The next few slides are just little recipes that you can copy and paste that are the most obvious uses for decorators. So here's a timer function. So this, if you want to know how long it takes for a single function to run, this takes the time before your function is called. It calls your function, then it takes the time after your function is called, does some math, and prints out the result. So this function took 1 millionth of it, or 1 millisecond. Here's a caching memoization function. So this is really handy if you have something that needs to do a lot of math several different times, so it won't repeat the same math over and over. So here I did Fibonacci sequence to 100 and got the result out almost instantaneously, whereas if you call this without that memoization function, I got bored of waiting. So I don't actually, that could have only been like 10 seconds. I don't know, I get bored easily. But still, this one, with the memoization wrapper, it was able to do that almost instantaneously.
After the first time.
Sure. So, don't. It was, on purpose. So then here's one we've already seen, which is login required and authorization. This is used in Flask quite a bit. If you've read Miguel Greenberg's, his Flask mega tutorial, he does decorators quite a bit throughout there for authorization stuff. They're really handy for that kind of thing. And you can see here that I'm actually raising an exception inside the decorator there. Here's a logging one, so you can just add a decorator that will log a function and what it does. And then here is my finale, which is you can also make delicious food with decorators. So here you can see I have now made a PBJ inside of a PBJ. Oh yeah, I did. Here are the resources I used for this talk. All of these say basically the same thing, but they are all good for different sections. So if there's anything you're not getting, definitely read through those. The real Python one is really solid. I would start there. And that's everything I've got, so thank you. The last link here is the link to my slides. That's GitLab, not GitHub.
All right, let's give Cameron a big round of applause. Thank you very much.